Welcome to ClickHouse Meetup in Singapore, our regular ClickHouse Meetup. How many meetups did we have here? Cheryl, do you remember?
This is since I joined or since only this year?
This year,
this
how
year
many?
is the third.
Yeah, and in total probably around.
Total 6 already, I think. 2 last year and then another one before I joined.
I personally visited maybe just only 3 of them. But I'm happy to be here, I'm happy to have you here. So the first presentation today is about AI. So AI today is kind of a boring topic. Everywhere you go, you hear AI, AI, AI. But anyway, it is going to be not only about AI, it is more about data. How is the AI made? From what data sets? How to analyze these data sets? Let's take a look. We have a large number of different data sets from the internet. And basically you have to grab everything, you have to take everything as the knowledge for your models. We have data just like internet pages, HTML pages. If you want, you can build your own internet crawler. If you don't want, there is a dataset named Common Crawl that contains monthly crawls of the internet. There is data from social network like Twitter, Stack Overflow, even Reddit or 4chan. Maybe if you train your model on data from 4chan, it is going to be less boring than usual. There is more boring data like Wikipedia or even scientific papers from Archive. So if you want your models to speak in a passive voice, train it on Archive. Well, it's going to be very smart. And there are prepared data sets, like not raw data, but already cleaned up for you, for research or for training, like educational models. Data sets like OpenWeb Text or FineWeb 2 are made from mostly Common Crawl with filtering, cleaning duplicates, cleaning some garbage. Basically, you don't need to do it by yourself, and it is quite convenient. So let's take a look at the sizes of these data sets. Common Crawl is presented every month from about several billions of web pages, 500 terabytes of uncompressed HTML pages, 100 terabytes compressed, and just 10 terabytes of text. So 10 terabytes of text, everything else is just HTML pages. Wikipedia, GitHub, they are specialized datasets, and FineWeb, OpenWeb Text, the pile are prepared datasets. Interesting how different they are. How different they are by their character. Can we just do some queries on these datasets with ClickHouse and play with these datasets? Let's take a look. You know, every time I see a new dataset, regardless of its volume, 100 terabytes, petabytes, it does not matter. The first thing I do is I go and load everything into ClickHouse, because ClickHouse is my favorite database. Hopefully it is also your favorite database. And I enjoy every minute when I have a chance to use ClickHouse and see it in action. And we are lucky because many of these datasets are open and openly published on Hugging Face and provided as a set of Parquet files, and the metadata is provided as an API. And we can use Hugging Face API directly. So let's take a look at this query. I am interested in the FineWeb dataset. The API is available as HTTP requests. And we have this dataset server that can just list all Parquet files. It will return an array. I will do array join. And we have 26,000 of files with total size of 46 terabytes. So let's keep in mind, 46 terabytes of Parquet files. Okay, not too big, not too small. Let's take a look in more detail. Almost 25 billion records And if we look at the uncompressed size, it will be 73 terabytes of uncompressed text, and with text and metadata, it will be 81 terabyte in total. And here are the files, here are the URLs, what to do. I will create a table. Hi Sam, welcome. I will create a table. And to create a table, I don't even have to specify its structure, because the structure can be inferred automatically from the Parquet file. I can just take, please have a seat. I will just take the first Parquet file and create a table as empty as select. I don't even have to specify the primary key. Here I use an empty primary key, order by empty tuple. And here is the table. It contains text, URL, date. For some reason, date is string, it should be date, but here is as it is in the Parquet file. Okay, now I will use ClickHouse to generate 26,000 insert queries. So here is a query that will use just a format function to generate more queries with insert into FineWeb, insert into this table. And after that, I will run all these insert queries in ClickHouse client in parallel. Here we have 50 threads, and we pipe everything into ClickHouse client. So what do you think? How long did it take to load 81 terabytes of data from all over the internet, data about all human knowledge for training language models into ClickHouse? How long did it take? What do you think?
1 minute.
1 minute? Okay, that's good. 1 day, okay, another hypothesis, not
30 minutes.
30 minutes. Any more?
2 hours.
Oh, interesting. So now we will look and see who are more experienced ClickHouse users, who are like not ClickHouse users at all. Maybe some of you are just users of, I don't know, Oracle. And you say, okay, it will definitely take 10 days. It cannot be as fast. Oracle is a serious like database. It will take at work for 10 days for you. No, ClickHouse is not like that database. Okay, it is still a real database, but with superpowers. Let's take a look. So it took 72 minutes. It is 1 hour and 12 minutes. Who was the winner? Who said 1 hour? You said 2 hours. Okay, you are the winner today. Not 1 minute, but you know, it depends on the size of the cluster. Maybe we can scale it up and load everything in 1 minute. But also another consideration, I just fetched this data at the same moment from Hugging Face. And probably Hugging Face will not let me do this stuff. And surprisingly, in this case, it did let me load this data. But more interesting that in ClickHouse, this dataset took just 33 terabytes compressed. It was 46 terabytes of Parquet files. Now it is 33 terabytes inside ClickHouse. And the question is why? Because Parquet is also columnar Retus format. It also uses compression. It also uses the same algorithm, ZSTD. And ClickHouse uses columnar compression with ZSTD. I don't know actually, I'm not sure why, but ClickHouse just does it better. ClickHouse does everything better. ClickHouse compresses data better. But okay, the first thing to do is look inside, explore this dataset. What is it made of? Let's take a look and run a query. Here is ClickHouse Play UI, here is a query. I will take a look at the top domains of URLs from this dataset. The query is run quite quickly with more than 100 gigabytes per second, and the data is made of Wikipedia, The Guardian, Business Insider, Fox News, Fanfiction, Telegraph, TripAdvisor, Bloomberg, Daily Mail, New York Post. So mostly Wikipedia and news. This data is pretty boring. Why does it have so many news outlets? No one reads them anymore. But okay, let's take a look. So FineWeb is 33 terabytes inside the ClickHouse, 25 billion HTML pages. Wikipedia, by comparison, is just 61 million records and 45 terabytes. Another question for you, like second chance. If I want to take English Wikipedia and load it into ClickHouse, how fast will it load? 61 million records, 45 gigabytes of data. I would like to be more precise. How fast it will load into my service in ClickHouse Cloud that I have created? Any ideas?
5 seconds.
You are absolutely right, about 5 seconds. How do you know?
I just calculated.
Yeah. So Wikipedia with all like distilled human knowledge, just 5 seconds to get everything into ClickHouse. Reddit will be slightly longer. It contains about 1 terabyte of data. Twitter, I don't have Twitter dump in my disposal. If I do, probably Elon Musk will be not too pleasant with that fact. This is just about 1% of all Twitter, and it is 2 terabytes of data. It is scraped by someone and put on Internet Archive. And probably you should not train language models on this dataset, and I did not. There is Blue Sky, which is much smaller. Hacker News also very small. There is GitHub, and if you count almost all repositories with forks, it will be about 300 terabytes. So it is the largest dataset, much larger than the dump of internet pages. If you want multimodal dataset, there is a Flickr. But let's take a look. So the point is, all these datasets fit into just a single ClickHouse cluster. Actually, it fits into a single ClickHouse service in ClickHouse Cloud, because everything fits into a single service in ClickHouse Cloud. ClickHouse Cloud is infinitely scalable. It can accommodate all this data. Now let's load all of this and compare by the characteristics of the content. I will do it in the most primitive way possible. I will just count words, count tokens. And for this I will create tables like ClickHouse, like Blue Sky token stats, Twitter token stats, Reddit token stats. And here is insert query that will look at the text, extract the words with function tokens, do array join, and for every word it will insert just one, number 1. And the summing merge tree table will sum everything in the background. In addition to tokens, I will also calculate bigrams. And it is also possible because in ClickHouse there is a function named array shingles. It will extract pairs of consecutive elements from an array named bigrams. It can extract trigrams and so on. And then here is another query. And this query will find the most contrasting tokens between different datasets. So which tokens are more prominent on Hacker News but less on Blue Sky, or vice versa. Let's run this query and see. Okay, let me copy paste it. Here is the query. Let me run it. It is fast, and on Blue Sky the top tokens are social, her, him, love, please, hope, his, today, so much, yeah, fun. I like it. On Hacker News it is data, Google, system, problem, using, that, it, there are. So Blue Sky is so much interesting, so much more interesting than Hacker News. I did it for all the examples, not only Blue Sky and Hacker News. So on Reddit, the top tokens are action, level, pretty content and yourself. I wanted to see what was before yourself, but it will be a secret. I will not tell it.
It's a bit word.
Probably. On Wikipedia, it was also surprising. I did not look at the top. I scrolled to the bottom, the least popular words. And on Wikipedia, the most unpopular word compared to other datasets is you. You are very unpopular on Wikipedia. Me as well. What else can I do? I can compare fingerprints of styles of different datasets. And interesting that you saw that Wikipedia, Reddit, Twitter, all of them are present in a much larger dataset, named FineWeb. So on FineWeb, we have almost every popular website. So why don't calculate something like a fingerprint from subset of this data for each website? And I will do it with this query. Don't worry, this query is pretty simple. It is just a few lines of SQL, but it is also very powerful. What do I do here? I define 1024 as a vector size, and I have tokens. For each token, I will calculate a hash function, city hash 64. And from this hash function, I will divide it by the size of the vector and calculate the position in this vector. Like this token will go to the dimension number 123. This token will go to another dimension. And for each token, I will add 1 to each position in the vector. And then we have like a histogram of distribution of tokens packaged inside just a single vector of 1000 elements. And let's take a look on the FineWeb dataset. How does it work at all? Interesting. Let's try to find websites that are similar to ClickHouse. So let me copy paste a query that will calculate cosine distance to ClickHouse. And we have clickhouse.com, yeah, imply, red panda, planet scale, source graph, confluent, dgraph, airbyte. It looks like my method is actually working. It is not my method, I did not invent it. But it was interesting to see that just a few lines of SQL code, and I get these vectors, I get the result that is looking plausible. What about trends on the internet? Let's calculate trends on Reddit of the word love. Here is love on Reddit. It is still strong. It was not so good in 2018. And here is ClickHouse on Reddit. It is stronger and stronger. What about Hadoop? Hadoop is not strong. It is falling. Blockchain. Blockchain is very popular in Singapore, and it is still popular, but not clear where the trends will go. The data does not answer. Blockchain is very volatile. Another question. If I have a multimodal dataset with not only text, but also photos, what would I do with this dataset? What should I do with a dataset with 1 billion of photos? What do you suggest? I have 1 billion of photos. Some of them are nice, some of them are not so nice. I will just put all of them on a map. Let's take a look. I created a service on the internet with photos. And here is the density of all photos. And I can press this button, and it will do like 1,000 of queries in ClickHouse. And for each tile, for each rectangle, for each square, it will find the best photo on on Flickr. The best photo for each location. And I can filter, analyze, filter by text, and so on. Actually, I would like to demonstrate this service live for you, because you might be interested. What is happening in Singapore? And here is my service. And here is a SQL query. By default, it displays not a photos, but a different data set. Now let me switch to photos. And here is just the density. And somewhere there will be Singapore, somewhere. It is difficult to find, it's so small. But it should be somewhere here. on a tip. So far this is just the density of the photos, but I can do analysis, like I can select something, and here is the report, and here are top photos. But what is more interesting, let me press this button, and we will compare the best photos for Singapore to, say, Malaysia or Indonesia. So, for example, what is this? This is not from Singapore. I don't know. Let's take a look.
And that's the clues to nowhere.
What? Okay, yeah, it's just somewhere. But this should be Singapore, but the photo is very stereotypical, I would say. There should be something interesting, like what is this? So every top photo is just a query to ClickHouse. And we can see it in developer tools. Like if we select this location, yeah, it does a few queries to ClickHouse. We can look at these queries in real time. We can even edit these queries to get something more interesting. Now also interesting question. Let's actually zoom in into Singapore, because I would like to know, it is a small city, but nevertheless different locations will give different results. What is especially interesting in your hometown? Is there something interesting in Singapore?
Airport.
I think that not airport, but okay, or this one. And there is one more dataset, also quite interesting. So it has not only photos, but airplanes, places of interest. It has birds. What are birds in Singapore, like here? And it has another dataset named U. What does it mean, U? Do you know? It should be about you. Anyone can guess? We have gifts if you give the correct answer.
Yeah, we do. We actually have shirts.
Is that DNA genome?
DNA. Note, I did not post my DNA to this service. More hypotheses. Travel activity. No, it is not about travel activity. And where can I get this dataset of travel activity? Will it be legal to take this dataset? It is about something else, which is particularly interesting. Where people live? No. ClickHouse users? No. We don't expose data about ClickHouse users. We don't even... it could be downloads, but no. And I would not put this data on a map. We don't have telemetry of this kind. And this is pretty interesting. And I would like to keep this question open. I don't want to tell the secret, you should know. But also this website is entirely open source, and you know, it is actually implemented in just a small single HTML page. You can press view source and get the answer to this question. So when you will ready, let me know. Okay.
IP address?
No, it's not about IP address. So, takeaways. ClickHouse is the database that makes everything easy. Regardless of dataset, regardless of data size, load it into ClickHouse and analyzing the data will be fun. And supposedly you can put all the internet into ClickHouse and then the internet will work better and faster. Thank you.
All right.
Thank you. Hi everyone, we just want to ask if anyone's got any questions for Alexey while he's over here, and we've got some prizes kind of give away.
Yeah, for the new who's the first timer here who's joining us today. So okay, just so that you know, we give T-shirts to good questions. It has to be like it has to make sense.
We have one special prize, right?
Huh?
One special prize,
We
right?
do? Where?
The selfie with Alexey.
No, it will be in
And okay, we have a question from all the way from Indonesia.
Yes.
He actually all flew here just to see it, by the way.
And
Andy.
he's spoken to Meetup before as well.
Yeah, he spoke in Meetup.
Hi.
Andy, go ahead.
Okay, maybe my question is not related to your presentation, but you have traveled all around the world about ClickHouse. What is the most unique use case of ClickHouse you get so far?
I like use cases that benefits the public the most. And there is one in particular that I like. It is from Sloan Kettering Cancer Research Center. They use ClickHouse to find a way to cure cancer.
Wow. That's really fun. That's good. Okay.
That is a good question.
Yeah, please.
I have two questions. One is, which data size is good fit for ClickHouse? Is it very huge, let's say 5 or 10 petabytes, or is it 1 petabyte, 5 tables, or smaller hundreds of GBs of tables? What would your recommendation be?
Starting from just a single gigabyte, starting from just 1 million of records, it depends not only on the size, but on what you do with this data. And if you have a small amount of data, but a huge number of queries, and you want every query to be processed fast, use ClickHouse.
And I have one more question, which is kind of difficult probably. It's about HyperDX. I have started exploring and I was curious, why does HyperDX not adhere to ClickHouse best practices?
And in particular, which best practices?
For example, force index by date or force primary index kind of settings. It doesn't work with those settings.
Actually, the main point is that it already works, and we can make it better by using these practices. Probably we should just patch it using our knowledge, but sometimes you have to do a full scan query without using primary key. Sometimes it is reasonable still. And my main impression that it is actually a good product.
You get a shirt just because you're testing tech stack right now.
There's one over here.
All right. You want a microphone?
I think I can just.
Okay.
So, I think one of the things that is a bit contrarian about ClickHouse, but also what actually gives it credibility to me is how core like leaky abstractions is to the building of ClickHouse. I was curious, what was like the first like big leaky abstraction, and since then, what's like your favorite leaky abstraction that makes ClickHouse, the magic that it is?
ClickHouse started when I written the code of iColumn, just a chunk of values in memory. And this is the main abstraction that is not so abstract.
I see. So that started it all.
Yeah.
Okay. Very cool.
Please?
So it's not a question about how versatile it is. So what is your view on AI? And in particularly how it will affect software development and operation? And can you give some example about how AI affect the development and operation of ClickHouse right now? It's some other things.
Sorry, you might need a microphone.
Yeah, hold on.
I can just repeat the question.
Are you sure?
How does AI affect daily work of our engineers and the operation of ClickHouse as a service? So the first part. So my goal for my engineers is not to force everyone use AI, but to make it possible. To provide access to latest tools. For example, we allow everyone to use Cloud Code, although it was not easy to me to make this through the company because, you know, there are many security and legal considerations. And it was my particular job to just convince people and find a way to find a common ground with this security and legal people. What?
Security blockage. Guardrail.
We have security people are very reasonable, like some.
We try to be pragmatic.
And after we make it possible, we see different amount of usage among different teams. And I would not say like the most experienced developers, not the most junior developers benefit more from AI. It is like something like just regular developers. It is not so useful for the main C++ code right now, but it actually is, if we look at different ways of using AI. So if we take it to extreme, like agents that write the code, it works quite well for our JavaScript and Go engineers, not so for C++. But if we look at the just helping with the code, starting with basic autocomplete and just a chat to remind about interfaces, about practices, it works for C++ as well. The overall metrics are still to be determined and calculated. Personally, I don't want to rush into conclusions. I just want to give people possibilities. And about our product. And we actually use AI agents in our daily work for business intelligence. So ClickHouse has MCP server, and ClickHouse Cloud has out-of-the-box integration with MCP server. You can enable it by a single click. It comes with security, authentication, and so on. And we use the same functionality on top of a database of resource consumptions of the customers. So we can ask questions like, what are the customers with services doing the most requests to GCS on GCP? And it will give a report, it will give a few reports. We also use a classic BI tools like Superset, but now more and more people just use chat and agents.
So how about like the operation of ClickHouse itself? Let's say you operate a very big cluster, like 1,000 of ClickHouse instance. You feel that, can you see that AI will have something in operating cluster at that time?
We just starting to explore, and no, today AI does not operate ClickHouse clusters on its own, but we're trying to explore how can it help investigating incidents. You can read an article, name it, can agents replace SREs? And the conclusion in this article that maybe in the future, but today maybe for a few cases, subset of cases. It is still in question, still being explored. There are interesting approaches, and many of these approaches is like giving a larger and larger prompt, making a custom logic, some loops that you basically manually adjust. And personally, I would prefer if AI will be slightly more intelligent.
So is ClickHouse still running on an open source model, or is like open core now?
And also, like, how do you plan to maintain the healthy balance between open source communities and also like development of exclusive cloud offerings that you are having in ClickHouse?
Very good question. We have two repositories. We have the public repository on GitHub. It is fully open source, Apache 2.0, and like 99% of development goes there. We have a private repository that is basically the same as public, plus a few additional features. And these few additional features represent the key differentiation of ClickHouse Cloud compared to open source ClickHouse. And we would like to keep this, the number of differences to the minimum. Not because we are so like just to do it for good, but also because we want to do it for ourselves. The complexity of maintaining two different repositories becomes larger if the difference is larger. So we want to keep these features isolated, but at the same time they should be crucial for the cloud service. And we selected that full separation of storage and compute, so dynamically scalable ClickHouse clusters, should be the key differentiation of ClickHouse Cloud. And I think it's a good decision. Yeah, please.
Yeah, I will have two questions. One regarding our position on the AI, because as a data platform, usually now I see two trends. One is that the data platform have the LLM capabilities built in, so that you use my preferred LLM and then you just send the data in. Another angle is that I work with any LLM that the user chooses. This is data platform, and you choose the LLM that connect and to meet the requirement. So what is our position for in our product?
We have a project in development to provide interaction with LLMs using user-defined functions. And most likely we will have a reasonable default, but it is still to be determined because let's say we will use like GPT-5 as the default. And the next year this model will be deprecated. But the customers will reference this model in their production, in their queries that even run in the background, like update table set column equals to invoke GPT-5. And then what should we do? Do we have to maintain like fallback models? So it is still to be determined. But at the same time, we want to provide UDF when the user will decide on their own what to do, not necessarily to invoke a model, any sort of action with network interaction and so on.
I see. Yeah, thank you. My second question, a quick one, is that now there also exists a lot of variations based on open source ClickHouse, like many of the leaders, for example, cloud provider, they have their own flavor of ClickHouse. So what is our position? Like, we treat them as a competitor, or we try to impact them, or it's a collaboration?
Typically, we just observe and monitor. I can name maybe like 5 interesting forks of ClickHouse, but none of them were successful. Some of them are, I would say, unfortunately, abandoned. Like there was a vector database on top of ClickHouse, but now I don't see updates. But at the same time, we have similar functionality in the main ClickHouse code base. There is a streaming database on top of ClickHouse. There are forks by Chinese cloud providers. And in some cases, I'm even happy to see when these forks are abandoned, because they are not like real, but potential competitors. At the same time, I don't think that any of the major cloud providers like AWS, GCP, Azure are willing to fork ClickHouse, because we are so good partner for them. Similarly to, say, Databricks, Snowflake, but we are open source, but at the same time, why to fork if we can provide the service, and they benefit from us, we benefit from them.
Hello. So thank you for your speech. So it's quite interesting, and I think I realized that on the ClickHouse, probably about 16 years ago. So I think that's quite amazing. Like even today, I was just looking at your GitHub, and then you're still committing despite like a very busy schedule. I think you are traveling over like many places. Like even on the web page, it says, well, your location and say, well, you have been to these places and now in Singapore. So I wonder, like with all this busy schedule, you probably have seen you probably have some idea, like throughout these 16 years, is there anything that you thought would be good, but it was kind of dropped out?
Good for what, sorry?
So, is there any good implementation that you wanted, but it was kind of dropped out throughout the history?
Yeah, actually a lot of them. And you are absolutely right about the schedule, because some tasks can be done in a few minutes, like do a glance on the code, a small pull request. Some tasks will require attention for a few hours, and some will require to take a few days, and ideally if no one will call me during these days. And it is more and more difficult to find this spans of time to do this work, but fortunately we have quite a large team. About interesting things that were dropped off. Yeah, unfortunately, yes. Like, what about support for streaming queries in ClickHouse? So we have databases like Materialize, Rising Wave. There is not a big market for this type of databases on their own, but there is Kafka and there is KSQL. And I see it's totally possible to do it in ClickHouse, but we should balance the priorities. Sometimes we have product people, and I have to collaborate with product people. They will tell me, we need this feature, please don't do that. And I say, if our engineers really want to do this, let them spend a certain amount of time. It does not always work, but at least I try to motivate people to find something interesting on their own.
I feel from like, this is kind of your baby, and then now he's a teenager, like 15, 16 years old. And do you kind of have some hope or some ambition for this baby in the future?
Don't grow up too quickly. Take time.
That's good advice for all parents, right? Any other questions?
I have a question.
Yeah.
Have you ever had an idea to create your own LLM? Because it would be the fastest one, right?
Not sure. It depends. So most of the companies, either they will take a budget in order of at least tens of millions, and this is for quite a small LLM. Or they just take the current, the best open source LLM like Qwen, and just fine-tune it. And sometimes they don't have to fine-tune a very large model if the scope is limited, and the model does not have to be like a really good foundational model to solve a small task. Even models with less than 1 billion, like in order of 100 million parameters, are still good, and this type of models can be fine-tuned quite quickly. If I find something that will really motivate creating a new model from scratch, we should probably do it. But so far we did not.